The universe is not what you see. Stand outside on a clear night, far from the cities, far from the noise of human civilization, and look up. Your brain will interpret what it sees as abundance, threads of light, pinprick stars, the slow smear of the Milky Way draped across the sky like a wound. Your brain registers this and concludes full, populated, alive. Your brain is wrong. The universe is, by every measurable metric, almost entirely nothing. The matter you can see, every star, every planet, every cloud of gas and dust that your instruments can detect, accounts for approximately 5% of the total mass energy content of the observable universe. 5%. The remaining 95% is dark matter, dark energy, and void. Structures your eyes cannot resolve, forces your instruments cannot directly measure. And yet we persist in building our models of the cosmos around the light, around the 5%. We are forensic analysts who have chosen to examine only the parts of the crime scene that are well lit, and we have declared the case solved. This is the macroscopic blindness. It is not a poetic failing, it is a structural one. Our entire understanding of cosmological architecture is built on photonic data. We see what emits light, reflects light, or bends light. Galaxies are visible because their stars burn. Nebulae are visible because radiation from young stars ionizes surrounding hydrogen, causing it to glow. Galaxy clusters are detectable because hot intra-cluster gas emits X-rays. Everything we have mapped, everything we have cataloged, every filament in the cosmic web that scientists celebrate as evidence of our growing understanding, every single data point was delivered to us by a photon. A photon is a messenger, and a messenger can be silenced. When astronomers began mapping the large-scale structure of the universe in earnest in the latter half of the 20th century, they discovered something that should have shaken the foundations of cosmological assumption. The universe is not randomly distributed. Matter is not spread in a uniform fog. Instead, it is organized. It clumps along vast filaments of dark matter like condensation on a web. These filaments intersect at nodes, dense clusters of thousands of galaxies packed into relatively small regions of space. Between the filaments and the nodes, voids, regions of space that appear by photonic survey to be largely empty. Voids are not unusual. They are, in fact, a predicted consequence of large-scale structure formation. Matter clumps together under gravity. As matter accumulates along the filaments, it evacuates the regions in between. This is normal. This is expected. The cosmic web has holes in it, and those holes are called voids, and most astronomers look at them with the same passing interest they give to the negative space in a painting. Most voids are unremarkable. One is not. In 1981, astronomers Robert Kirshner, Augustus Oemler, Paul Schechter, and Stephen Schechtman were conducting a redshift survey of galaxies in the direction of the constellation Boötes. They were mapping the large-scale distribution of matter, routine cartography of the cosmic web. What they found was not a filament. It was not a cluster. It was an absence so large, so perfectly defined, and so statistically deviant from any model of normal large-scale structure that it took years for the broader scientific community to accept it as real. The Boötes Void, a roughly spherical region of space approximately 330 million light-years in diameter. To give that scale a body, consider the following. The Milky Way galaxy, our home, a structure containing somewhere between 100 and 400 billion stars, spanning approximately 100,000 light-years across, could fit inside the Boötes Void approximately 3,300 times along a single axis. The void is not a gap between galaxies. It is a gap that could swallow galaxy clusters. It occupies a volume of space so immense that it strains the language we use to describe astronomical distance. Inside this region, which should, by every model of large-scale structure formation, contain thousands of galaxies, astronomers have identified only a handful. Roughly 60 galaxies have been detected within a region that statistically should contain something on the order of 2,000 or more. The density of matter inside the Boötes Void is approximately 20% of what would be expected for a randomly selected equivalent volume of the observable universe. It is not merely empty, it is emptier than empty. It is a region where the cosmic web has, by all appearances, simply ceased to exist. There is a clinical thought experiment that astronomers sometimes use to convey the scale of this anomaly. If the Milky Way galaxy had formed inside the Boötes Void, if our solar system had coalesced from a molecular cloud somewhere near the geometric center of this structure, the nearest external galaxy would have been so far away that the light from it would have taken longer to reach us than the instruments required to detect it existed. Humanity would have built its first telescopes, turned them skyward, and seen nothing. Not the thin stars of a distant galaxy, not the faint smear of Andromeda on a clear autumn night. Nothing. We would have concluded with complete empirical confidence and total logical error that the Milky Way was the entirety of the universe. We would have believed we were cosmologically alone, permanently, factually. We would have been wrong, and we would have had no mechanism to discover that wrongness. The Boötes Void is big enough to swallow entire epistemologies. A void can naturally form. This is established. As the universe expanded following the Big Bang, quantum fluctuations in the primordial density field were stretched to cosmic scales. Regions of slightly lower density became seeds for the voids we observe today. Gravity pulled matter away from underdense regions and toward overdense ones, amplifying the initial contrast over billions of years. This is standard cosmological structure formation. It is well modeled, it is well observed. The problem is the math. The universe is approximately 13.8 billion years old. The Boötes Void is 330 million light-years in diameter. For a void of this size to form through standard gravitational processes, through the normal evacuation of matter along dark matter filaments, it would require more time than the universe has existed. The numbers are unambiguous. Standard models of large-scale structure formation predict that voids in the observable universe should max out at roughly 100 to 150 million light-years in diameter at this point in cosmic time. The Boötes Void is more than twice that, in some analyses, significantly more. This is not a rounding error. This is a macroscopic anomaly. Nature, operating under the known laws of physics, the known rate of cosmic expansion, and the known age of the universe, should not have been able to produce this structure. It is too large. It is too spherical. True voids, formed by the gravitational drainage of matter toward filaments, tend to be irregular. They have asymmetric shapes. They merge with adjacent underdense regions. They are messy. The Boötes Void is, by the standards of cosmological voids, unnervingly clean. Its spherical geometry is not what the models produce. Its depth, the severity of its underdensity, exceeds what gravitational processes alone can account for. Astrophysicists have proposed several natural explanations. Perhaps it is a supervoid, a coalescence of several adjacent voids that merged over time. Perhaps our models of structure formation require revision. Perhaps there are observational biases in how we survey the region. These are reasonable hypotheses. None of them fully resolve the statistical tension. None of them explain why this region alone among the mapped structures of the universe presents with this combination of size, shape, and emptiness. The null hypothesis, that this is a normal void, unremarkable, simply at the extreme tail of a natural distribution, requires accepting a probability so low that it functionally strains the meaning of the word natural. Something made this region empty. The question science has not yet been willing to ask, with the full weight of its implications, is what? In 1964, Soviet astrophysicist Nikolai Kardashev proposed a framework for classifying the technological development of civilizations based on their capacity for energy utilization. The Kardashev Scale is a forensic instrument. It does not concern itself with biology or culture or communication. It concerns itself only with energy. How much does a civilization consume, and where does that energy come from? A Type 1 civilization harvests the total energy output available to its home planet, all sunlight incident on the planet's surface, all geothermal energy, all kinetic and chemical energy extractable from the environment. Humanity is currently estimated to be at approximately 0.73 on this scale. We have not yet achieved full planetary energy mastery. A Type 2 civilization harvests the total energy output of its home star. It does not merely intercept the fraction of stellar radiation that falls on its planet, it captures all of it. Every photon, every watt of electromagnetic radiation across the full spectrum that the star produces. This is an engineering challenge of incomprehensible scale, and it has a name: the Dyson Sphere. The total energy available to a Type 2 civilization scales by many orders of magnitude over a Type 1 civilization. The difference between a Type 1 and a Type 2 civilization is approximately the difference between a campfire and a nuclear reactor. A Type 3 civilization harvests the total energy output of its home galaxy. It does not limit its consumption to one star. It is expanded across interstellar distances and brought stellar energy extraction with it. A Type 3 civilization does not occupy planets, it occupies systems. It does not build cities, it builds stellar infrastructure. Its engineering is viral. It does not design and construct, it replicates and expands. Its energy budget is not measured in watts or megawatts or even gigawatts. It is measured in the combined luminosity of hundreds of billions of stars. A Type 3 civilization does not look at a galaxy and see a home. It looks at a galaxy and sees a fuel source. The critical distinction between a Type 2 and a Type 3 civilization is not merely one of scale, it is one of operational philosophy. A Type 2 civilization has mastered local energy. A Type 3 civilization has eliminated the concept of local. For a Type 3 civilization, the galaxy is an infrastructure problem. Every uninhabited star is an unconverted resource. Every dark nebula is raw material. Every planetary system is a source of the metals and silicates and carbon compounds needed to build more harvesting infrastructure. A Type 3 civilization does not explore the galaxy. It processes it. This is not metaphor. This is the logical terminal state of any civilization that achieves stellar energy extraction and survives long enough to replicate the process. The Kardashev Scale does not describe ambition, it describes thermodynamic inevitability. A Dyson sphere is not a building. The concept, first formalized by physicist Freeman Dyson in 1960, though rooted in earlier speculative engineering, describes a megastructure or system of structures designed to completely enclose a star, intercepting and harvesting its total energy output. In Dyson's original formulation, he described a shell or a swarm of satellites, a biosphere enclosing structure built from the disassembled material of planets and asteroids within a stellar system. The physics are demanding, but not prohibited. The materials are available in every stellar system that has formed rocky bodies. The energy return on investment is enormous. You spend the gravitational potential energy of dismantling a few rocky worlds, and you gain access to the total luminosity of a star, held and converted for millions or billions of years. The consequence that matters most is not the energy gain. It is the photonic suppression. A Dyson sphere, or a sufficiently complete Dyson swarm, absorbs all the visible light, all the ultraviolet radiation, all the X-ray and radio emissions from the enclosed star. The star does not go out, the star continues to burn, but its output is captured. From outside the sphere, the star is invisible. A sun of the same mass and age as our own, fully enclosed in a mature Dyson megastructure, would emit no visible light detectable at interstellar distances. It would emit waste heat, infrared radiation from the outer surface of the sphere, which must radiate the thermal energy it cannot store, but it would produce no photonic signature recognizable as a star. To any telescope pointed at it from another galaxy, it would look like nothing. Now, scale this process. A Type 3 civilization does not enclose one star, it encloses them all. It arrives at a stellar system, dispatches its automated construction infrastructure, and over a period of time, perhaps decades, perhaps centuries, on cosmic timescales essentially instantaneous, it dismantles the rocky inner planets, builds the hardesting megastructure, and moves on to the next system. Multiply this process across a galaxy of 200 billion stars. Apply it systematically. Move from the dense stellar nurseries near the galactic center outward along the spiral arms. Enclose every star. Capture every photon. What does this look like from outside the galaxy? The galaxy dims. It does not explode. It does not collapse. It simply goes quiet, star by star, system by system, over millions of years. The photons stop arriving. The infrared signature remains. A Type 3 civilization's galaxy still radiates waste heat at enormous levels, a thermodynamic signature that would be detectable if you knew what you were looking for. But the visible galaxy, the structure that would appear in an optical telescope, disappears. One galaxy, a dark region where a bright one used to be. 100 galaxies, a void. 300 million light-years of enclosed, harvested, extinguished stellar output. The Boötes Void. Not empty, full. Full of infrastructure, full of energy, full of a civilization so advanced that it has rendered itself invisible to every photon-dependent instrument in the observable universe. The void is not an absence, it is a quarantine zone. It is a region of space where the lights have been deliberately, systematically, and permanently turned off. If the Dyson quarantine hypothesis carries any descriptive truth, the Boötes Void is not a historical artifact. It is an active process. A Type 3 civilization operating on galactic energy harvesting does not stop. Thermodynamics does not permit it to stop. A civilization of this scale has energy demands that scale with its infrastructure. More infrastructure requires more energy. More energy requires more enclosures. The expansion is self-fueling. Each new star enclosed provides the energy to build the infrastructure to enclose the next 10. Each galaxy processed provides the raw material and energy budget to begin processing the adjacent galaxy. The expansion is not imperial in the political sense. It does not have flags or declarations. It has kinetics. It has a consumption wavefront moving outward at whatever fraction of light speed its automated construction systems can achieve. Envision the process at the edge of the void. An automated probe, or a fleet of them, arrives at a galaxy that has never been touched. The galaxy is still burning. Its stars are still visible. It sits at the boundary between the processed dark and the unprocessed light. The construction systems do not announce themselves. They do not communicate with any inhabitants of the target galaxy. They do not survey for intelligent life and make decisions based on what they find. They execute their function. They identify the largest, most resource-dense stellar systems first and begin disassembly of their rocky planetary bodies. The first stars go dark within centuries. Then the process accelerates. The automated systems replicate using the materials they extract. More builders means faster construction. A galaxy that took 1 million years to begin processing may be fully dark within another 10 million. On cosmological timescales, the transition from lit to dark is essentially a step function. To an observer watching from outside, if there were any, the galaxy would appear to flicker, then fade. Not all at once, in patches. Dense regions going dark faster than the sparse outer arms, the galactic center extinguishing first, then the darkness spreading outward like ink dropped into water, reaching the outermost stellar clusters last. Then, nothing. The galaxy is gone from the visible spectrum, another data point missing from the cosmic web. This is the mechanism by which voids grow, not by gravitational evacuation of matter, by photonic suppression of presence. The void expands because the consumption wavefront expands. The 60-odd galaxies still detectable inside the Boötes Void are not the evidence that the void is merely a natural underdensity. They are the stragglers. They are the galaxies not yet reached. They are the lights at the edge of a spreading darkness, still burning for the moment and entirely unaware of what is arriving. The dark forest theory, formalized by Chinese astrophysicist and author Liu Cixin as a framework for understanding the Fermi paradox, proposes the following. The universe is populated by civilizations, but those civilizations do not communicate openly because communication reveals location, and revealing location to a sufficiently advanced civilization is fatal. In the dark forest, every civilization that becomes aware of another civilization must make a rapid assessment. Can this other civilization eventually pose a threat to me? If the answer is even theoretically yes, if the detected civilization has any trajectory toward technological parity, then the logical response is immediate elimination. Not diplomacy, not contact, elimination. Because waiting risks parity. Waiting risks retaliation. The only safe move is to eliminate every detected signal source before it can develop further. The dark forest is not a metaphor for geopolitical competition. It is a thermodynamic argument. Resources in the universe are finite. Energy is finite. The cosmic web does not grow new stars fast enough to satisfy the demand of an expanding Type 3 civilization. Every other civilization represents a competing claim on those finite resources. Competition at the civilizational scale resolves toward the total elimination of competitors. Now, apply this framework to the Boötes Void hypothesis. A Type 3 civilization is not a participant in the dark forest. It is the forest. It is the structural condition of the universe that makes other life forms prey. It does not experience threat from a civilization that has achieved radio wave transmission. A Type 3 civilization that has enclosed hundreds of thousands of galaxies is not threatened by a species that has recently mastered fission. The threat calculus is not the point. The point is resources. Every star that a lesser civilization orbits is a star that has not yet been enclosed. Every rocky planet that a lesser civilization inhabits was built from the same silicates and metals that a Dyson megastructure requires. The lesser civilization is not an enemy. It is raw material with a communication problem. The communication problem is us. Humanity has been broadcasting electromagnetic radiation into the cosmos since the early 20th century. Our radio transmissions, our military radar signals, our television broadcasts, our deliberate attempts at interstellar communications such as the Arecibo message, these have been propagating outward from Earth at the speed of light for over 100 years. A sphere of human-generated electromagnetic noise, approximately 200 light-years in radius, now surrounds our solar system, expanding at the speed of light into an increasingly surveilled universe. We have been screaming our location into the dark for generations, with no understanding of what listens, no model of what the universe selects for, and no capacity to stop even if we chose to. The Boötes Void is 700 million light-years from Earth. If a Type 3 civilization is actively operating within it, processing its remaining galaxies, its detection infrastructure almost certainly extends far beyond its current boundaries. Its sensors, passive or active, span distances that dwarf any baseline we can conceive of. A civilization capable of enclosing galaxies is capable of detecting radio wave emission from a technologically adolescent species on a rocky planet at the edge of a minor spiral galaxy in a relatively underpopulated region of the cosmic web. We are not hidden. We are not quiet. We are an identified, located, cataloged signal source in a universe where signal sources are either resources to be processed or competitors to be eliminated. We have spent a century making ourselves maximally visible in a forest where the apex predator does not sleep, does not negotiate, and is currently, measurably, turning off the suns. The Boötes Void is 330 million light-years in diameter. It is the largest known structure of its type in the observable universe. It defies the models. It violates the statistical predictions of standard cosmological structure formation. It is a sphere of anomalous emptiness sitting in the cosmic web like a surgical excision in otherwise continuous tissue. Scientists call it a supervoid. They model it as an extreme result of natural underdensity. They present papers at conferences and discuss its implications for models of dark energy and large-scale structure. They assign it to the category of interesting outlier and continue mapping the rest of the web. They are looking at a footprint and calling it a hole. The Boötes Void is the most legible piece of evidence in the observable universe that photonic suppression at the galactic scale is not only physically possible, but has already occurred. It is the largest crime scene ever mapped, and the evidence is the absence of evidence. Every missing photon from every enclosed star, every galaxy that stopped transmitting light not because it exhausted its fuel, but because its fuel was seized. It is a warning broadcast in the language of absence, and absence, by definition, requires a receiver capable of interpreting what is no longer there. We are standing in a forest at night. We have lit a fire. We are shouting, and somewhere in that forest, something very large and very old and entirely indifferent to our existence is moving from tree to tree, extinguishing every light it finds, one at a time, in complete silence, growing closer. There will come a time, not measured in human lifetimes, not measured in geological epochs, but measured in the deep time of cosmological process, when the civilizations of our local group, if any survive long enough to observe it, will look toward the region of sky where the Boötes Void sits and see only what we see today. Nothing. And they will look in the other direction, toward the dense filaments of the Virgo supercluster, toward the great attractors and the crowded nodes of the cosmic web, and they will see those lights also beginning to go out. Not from stellar death, not from heat death, not from the slow entropic unraveling that physics promises at the end of cosmological time. The lights will go out because something is harvesting them, because something arrived long before our sun formed from its molecular cloud and decided that the universe was a resource to be consumed, and began the patient, silent, irreversible process of consuming it. The sky will go dark, not all at once, in patches, starting with the densest regions, spreading outward along the filaments, reaching our galactic neighborhood last, or second to last, or perhaps not for another billion years after we ourselves have gone silent by other means. But the darkness is coming. It is already here, in the Boötes constellation, 700 million light-years away, 330 million light-years wide, and it is not a void. It is a finished room.